This video will lay the mathematical groundwork needed to understand feature representation. For some of you smarty cats, this might be easy peasy. Still, hang in there because the terminology that we use in regular math class is slightly different from the terminology that we use in machine learning. And trust me, you really don't want to get confused later on. Let's start with the concept of dimensionality. 0D is what? A point. 1D is a line. 2D is a plane, something like a square. Good job! Just kidding, I have no idea if you were responding to me. Who knows, I might just be meowing into the void. Anyway, now let's stop at the 2D case. Normally, when you want to draw graphs in math class, we use the Cartesian coordinate system. We have an x-axis and a y-axis. Now that we're doing machine learning, we're not going to label our axes as x and y. We're going to label our axes as x1 and x2. Why? Because x1, x2, etc. are reserved for our features, and y represents our label. You see, the number of dimensions we deal with is closely related to the number of features that we're working with. It's not necessarily the same, and we'll learn why in future videos. But back to the 2D case. As you know, the 2D case is easy to draw and visualize. That's why a lot of times when I will draw out explanations of how a machine learning model works, I'll draw it out in 2D. But note that in machine learning, we could be easily working with tens, hundreds, or even thousands of dimensions. Now on to 3D. 3D is a volume, something like a cube. So if we were to draw out the Cartesian coordinate, what would be the axis? Would it be x, y, z? No, we are now in Miss Paws' machine learning course. The axes would be x1, x2, and x3. You get the point. Now on to scalars and vectors. You might have come across these terms in a physics class. If not, no worries. These terms are integral to machine learning. Scalars are physical quantities with magnitude. They're numbers like -1, 2, 3.5, and even pi. Vectors are physical quantities with magnitude and direction. Let's draw a couple of vectors. Here's what the vector 2, 2 looks like. We start from the origin and draw an arrow to the point 2, 2. Here's what the vector -3, -1 looks like. We start from the origin and draw an arrow to the point -3, -1. We represent features as column vectors. Here's what column vectors look like. x1 equals 2, 2, and x2 equals -3, -1. By the way, these are examples of 2D column vectors. We know that because there are 2 entries in each vector. Also, we just graphed these vectors in 2D space. The arrows above x1 and x2 signify that they are vectors. In machine learning, vectors can also be thought of as a coordinate. Being the benevolent feline overlord that I am, here's a warning I'll graciously bestow upon you for free. No blueberry muffin offerings required. Don't get confused by terminology. We will use x1 and x2 with arrows to signify different data points in our dataset. x1 and x2 without the arrows denote the axes. Got it? Well, that's all I have for today. In the next video, we'll use what we learned to make sure our features are all numerical and interpretable by a computer. See you next time. Want to go deeper into AI? Check out the MehtA Plus certification program. Details in the description. Don't procrastinate.
ME to the HTA plus, that's my zone. Leaping hurdles, breaking boundaries, never alone. Miss Paws on the block.